writing an equation given its roots. So up until now, I've been giving you an equation, like this one here, and you have been factoring, t-chart, and you're getting the roots. Yes? So now we're just going to go the other way. Now I'm writing all this work out here to show you we're going to be going backwards. So if x equals 4 is the answer, or the 0, so the factor then is x minus 4. So basically you have to get it equal to 0 again. So if you're given a root, get it equal to 0. Now you have the factor, and then you can multiply it together. So we're going backwards. Now there is an easier way to do it, but that's your fail-safe just in case and you don't know. Okay, so you already know that roots can be real, irrational, rational. They can be the same. You can have zeros as a roots, 2 zeros or 2x minus 2's or whatever. You get the idea. The degree of an equation determines the number of roots. We say this all the time. If it's a 4th degree equation, you have 4 answers. So now it's going to be useful. Finally, what you may or may not have realized is that anytime you have an imaginary or irrational roots, they always follow in pairs. So if I tell you one of the equation's roots is 3 minus 4i, that's not the only one. There's another one. The other root is the conjugate of it. So remember, that's 3 plus 4i is the other root. So that's just useful in the future. So yeah, I just did this part. Not exactly my thing, but anyway. So I just talked about that. If they tell you x equals 3 is are the roots, so then you just get it set equal to 0. So this is what I did above, but just in an official form. X minus 3 is a factor. Okay, so this is a root or a 0. The factor is when it's set equal to 0. What is that part? So same deal here. I want to get it equal to 0. So x minus 4 equals 0. So this is a factor. So that means x minus 3 is a factor, x minus 4 is a factor. So if I multiply these together, using our box method or whatever you want, you should get that equation that we got the last time, x squared minus 7x plus 12 equals 0. Okay, now you can do the same thing with something like this. If one of the roots is 3 plus radical 7, the other is 3 minus radical 7. So the problem with that is, though, with something like that, getting it set equal to 0 is a big fat mess. So we would have to subtract both of these and move them to this side. So minus 3 minus radical 7. So the actual factor is x minus 3 minus radical 7. So this is like a trinomial. And the other factor is x minus 3. And x, we have to move it over, x plus radical 3. And to do that would be one big, whatever, is x negative 3. I'm not doing this because if you want to, this is always a possibility. Okay, you would multiply all these pieces here and then add them up, and then you would have your actual equation. What will happen, because these guys are conjugates of each other also, what will happen is all the radicals will go away, and it will be a nice equation, but it's still not an easy thing to do. So we do have a slightly easier route to take to do this. What we do is we find the sum of the roots, which means to add them, and the product of the roots, to multiply them. And remember the AM method, that's what this is all about. And that's how this works. So if you want to write something in an equation in standard form, the A is always 1 to start, at least, okay? The B is always negative the sum. So you add the roots together and you get the sum, and then C is always the product. Remember our AM method when we multiply? Same idea. Okay, so in this horrible problem, it makes it a little easier. So when we write an equation, the three things we always need are A, B, and C. Okay? A is 1, as I said. It's consistently 1, unless we get fractions, and I'll show you how to do that in class. Okay, and we want to find the sum of the roots. So first, let's find the sum. 3 plus radical 7, 3 minus, you line them up and add. When I add, these, bam, are gone. We just get 9. Remember, B was negative the sum. Okay, so it's whatever the sum is and just change the sign. And then the product, okay, is you have to multiply them together. 3 radical 7, 3 radical 7, and this one's negative. So it's 9. And then this is negative radical 49, which is just plain 7. So these cancel out, and you add these two up. 9 minus 7 is 2. So this equation is x squared, because it's 1x squared, minus 9x plus 2 equals 0, because we want to write an equation. That's it. You add them together, multiply them together, and we create the equation. Okay, so for this one, this is telling you that there are two roots that you know of, this one and this one. So the problem with that is that when you have anything with an I or a radical, it always has a pair. That's what the quadratic formula, negative b plus or minus the square root of b squared minus 4ac, all that meant that there were two answers whenever you get that radical. So if x equals 3 plus 2i, well then one of the other answers is x equals 3 minus 2i. Okay, and then another root was x equals 5. Oh, whatever. So that's a 5. So those are the three roots. So we know in the end we're going to have a degree equation of x cubed. Okay, x cubed is going to be our highest because we have three answers. Remember we went through that? Awesome. Okay, so all we do is we have to work in pairs. So we can't do, when we write in a quadratic equation, this is a cube. So I can only work with two at a time. Work with the conjugate pairs first. Okay, and write a trinomial using those two. Okay, so if you want to make a cubic, it's going to take a few steps. So first we're going to make a quadratic, which is an x squared. And we're going to figure out our a, b, and c if these two were the only two I was writing the equation for. And we're going to deal with this one later. So a, remember, is 1. B is, if I add these two together, so this is the sum of the roots, 3 plus 2i, 3 minus 2i. Add them together, I get 6. So when I put it in for b, the sign changes. Okay. And then when I multiply, I mean, you might get used to you could do this in your calculator, especially with i's. Actually, you can do this in your calculator regardless, because the irrational parts always go away. So it's minus 6i plus 6i, and this is a negative 4i squared. Remember, I squared is negative 1. That makes this a positive 4. So it's 9 plus 4, or 13. So 13 goes here. So if these two were just the equation, it would be x squared minus 6x plus 13 equals 0. So this is one part of it, but then this here is the other. So we have to deal with that. So that's when we use what we talked about before, okay, where you have to get it set equal to 0 to find out what the factor is. So x minus 5 equals 0. X minus 5 is the factor. So what we have to do is we have to multiply these two together. And then we have a final equation. So it takes a little bit of work and room, apparently, to do this. Okay, so it's x squared minus 6x 13, x minus 5, x cubed. Okay, so 30x, and then okay, and then we write the whole equation out. Now I just did that really fast at 5:30 in the morning, so please tell me if I made a mistake in that text. So I did just add these two up, and now this is our equation. So notice it's a third degree equation. Okay, it's a third degree equation in the end because I have 1, 2, 3 roots. Even though they only gave me one here, always it comes in pairs. Okay, one last thing I do want to say, if we have a multiplicity, so if I say x equals 3 with a multiplicity of 2, all that means is, and we're going to talk about this tomorrow and whatever in class, the factor that we're talking about, x minus 3, happens twice. So you would have to multiply this out and do it. So part of a recap, we're going to revisit multiplicities throughout the course, but when you're writing an equation, use the sum and the product of the roots and go through and take care of it. Bye-bye.